is 9.2. Second lesson on probability. This is about two-way tables and conditional probability. Let's jump right into this. Example number 1 is about vocabulary. The conditional probability is the probability of an event occurring when we already know that another event has occurred. Let me read that again. Conditional probability is the probability of an event occurring when we already know that another event has occurred. And the example, this P is probability of lung cancer given that they smoke, would mean the probability of a person getting lung cancer given that the person smokes. And so this symbol right here we read as given or given that. So the probability of a person getting lung cancer, this is the probability, that's what that P means. The probability of a person getting lung cancer given that they smoke. And so then it asks the question, which do you think is greater? The probability of lung cancer given that they smoke, or the probability of lung cancer? Okay. What do you think? Let's consider here. The conditional probability formula. Let's see, it's the probability of A given B, or given that B has already happened, is the probability of A intersection. This is the intersection right here, remember? B over the probability of B. Or the total in A, we can also read this as and, the probability of A and B over the total number in B. This will make a little more sense in example 2. Let's go over here, look at example 2. Example 2, it says show your thinking. Fill in the two-way table using the given Venn diagram. So we've got a Venn diagram in which this circle right here represents that they have an iPhone. This circle represents that they have a dog. And so how do we fill in this two-way table? Let's see. Excuse me. Okay. This part right here represents the people that have an iPhone and also have a dog. And that would be 27. Let's see. This space right here represents those that have a dog, but no iPhone. But if they have a dog, they have to be in this circle of those that have a dog. But outside of the circle that has an iPhone, that would be 16. Okay, this circle right here is those that have an iPhone, because they're in this column of iPhone, but they have no dog. So iPhone, no dog. Once again, it has to be in the circle of iPhone, but has to be outside the circle that has a dog. And so that would be at 37. And then this circle right here has no iPhone and no dog. So it has to be outside of both of these circles. So these are the two circles. 22 is our number there. And then for the totals, we just have to add up each row and then each column, and then we'll go from there. Okay, so 27 plus 16, we say 27 plus 16. You can just do this in your calculator, or you can do it by hand. It's a good idea to do some mental arithmetic. 7 plus 6 would be 13. 2 plus 2, there, 4. So this is 43. And then we've got 37 plus 22. And 7 plus 2 is 9. And 3 plus 2 is 5. And so this is 59. Now, we're going to add up each column as well. So 27 plus 37. 27 plus 37. 7 plus 7, 14. And then we've got 3 plus 3, and that's 6. And then, so that's 64 right here. 27 plus 37. And then 16 plus 22. 16 plus 22. 6 plus 2 is 8. And 2 plus 1 is 3. So this is 38. Now, excuse me. So this is where a lot of students kind of make a mistake here. They add up these two numbers to get the number here. Then they add up these two numbers to get the number here. And then they add those two numbers together. No, they just have to match. It's all the same. These are all the same people in here. Those that have a phone, those that don't have a phone, those that have a dog, everybody in here. They're all the same people. So we only add and then check the two totals. So we can go, okay, 43 plus 59. 43 plus 59. And 9 plus 3 is 12. 5 plus 4, 5 plus 5, that's 10. So this is 102. And then we're just going to add the other side to check. These two right here should add to 102 as well. If I take 64 plus 38, 8 plus 4 is 12. 6 plus 4 also 10. And so yes, that works. So we add them. We add these and we add these, and they should come to that same value here, which is the total. And you'll find that if you add all of the numbers in your Venn diagram, so if I add, let's see, if I add 37 plus 27 plus 16 plus 22, and I just add those all together, that should equal the whole amount in the survey, in the interview, in the sample space, you could think of it. So 7 plus 7, that's 14. 6 plus 2, that's 8. And 14 plus 8 would be 22. So I'm going to put 2 right here and carry the 2 up here. So then I got 3 plus 2, that's 5. And then this 2 plus this 1 and 2 together, that's 3. Plus that 2 is also 5. So 5 plus 5 then is 10. That's 102. It's the total number in your sample space. And so that number should equal what we've got in the table since it came from those values. All right, let's look at example 3. More practice now. It says we're just going to go through and fill in the values just like we did before. 5 plus 1, 6. 3 plus 5, 8. So this is 86. 26 plus 47. 6 plus 7 is 13. And then 4 plus 3, that'd be 7. So that's 73. And then, let's see, 35 plus 26. I don't know, 5 plus 6 is 11. And so that would be 61, I think. And then 51 plus 47. Let's see here. 7 plus 1 is 8, and 4 plus 5 is 9, so it's 98. Now, if I add those, 8 plus 1 is 9, and 6 plus 5 is 15, so this is 159. Now, just to double check, 86 plus 73. 86 plus 73. I got 6 plus 3, which is 9. 8 plus 7, which is 15, and that's 159, which is the same here, so we're good. That's what we wanted to check. Excuse me. Okay. So this example, so these go. I forgot to read this. It says an ice cream shop keeps track of whether people order vanilla or chocolate ice cream, and they order and whether they order a sugar cone or a waffle cone. So we fill in the marginal totals and find the requested probabilities. So the marginal totals, we did that part. That's what we just did. Now we're going to find the requested probability. So this right here, this means what is the probability that somebody comes in and order vanilla given that they ordered a sugar cone? And if you recall, where's vanilla and sugar cone? So the first thing you do on the top part, it's both vanilla and sugar cone. So if we look at that, that's the formula. It says the total in A and B. So A and B, that's vanilla and sugar cone. That's this number right here. But it's over the total in B. And since B is the second one, this is, so just to kind of help you out here, this is A and this is B. So the given is sugar cone. So what's the total in B? 86. So our probability then is 35 over 86. Excuse me. And so we can then go to our calculators and we can just plug this in. I'm gonna clear that. Maybe I'm not gonna do that. Let me just keep going here. I'll come back to this in just a second, but let me close this. See if I open it up again, if maybe I can show you stuff that I've already shown you. I've shown you this before. However, because I know how well you pay attention, I'll show you again. So I'm going to open up the calculator. Give that a moment. We'll let that reset, and then we'll just keep going here. So the next one, it says the probability of chocolate given that they chose a waffle cone. So let me erase this and erase this. Chocolate and waffle. Chocolate and waffle is right there. That is both chocolate and it's also waffle. And so it's this space right there. That's the 47. Now, 47 is our numerator. But what's the denominator? It's over waffle cones. So it's, a lot of students get confused. Is it 98 or is it 73? It's B. It's waffle. So it's 73, not the 98. So this is 47 over 73. And let's see how our calculator's doing. Okay, let's go back, see what we got here. 35 over 86. So I'm going to go just to bring that, that's just a, what did I say? 35 divided by 86. I hit enter, and that gives me a decimal. And because we're probably asked around that to 2 decimal places, this is a 4 and then a 0. That was the 2 decimal places, but I have to look at the one right by it. That's 6, means that this 0 rounds up. If it's 5, 6, 7, 8, or 9, it rounds up. If it's 0, 1, 2, 3, or 4, it rounds down. But since this is a 6, this 0 rounds to 1. So it's 0. This is approximately equal to 0.41. Is that right? Yeah. But if I want to get 2 decimal places after moving this to a percentage, I move this decimal place over here between the 0 and the 6, and then it's going to have that 6, 9, but since the 7 is there, it's going to round the 9 up to 10, so I'm going to make that a 0 and make this a 7. So it's 40.70. This is approximately equal to 40.70%. And so, excuse me. I'm going to rewrite this over here to give myself a little more space. That's 47 over 73. And what is that one as a decimal? 43 over 73. 47 divided by 73. Is that right? Yeah. And then that would give me 0.64. The 3, this 3 rounds, because it's lower than 5, rounds this to 4. So this is just 0.64. So this is then, again, I'm going to change that equal to, is approximately equal to 0.64, which is also then approximately equal to 64.38. 64.38%. And all right, let's keep going here. Let's see what we've got. Waffle and vanilla. So look at waffle and vanilla. That's 26 out of vanilla. So waffle and vanilla, but that's out of vanilla. So these are our two that we're dealing with. So it's 26 out of 61. So 26 divided by 61, and that gives us 0.462. So that's 0.43. This is approximately 0.43, which again is approximately equal to 42.62. 42.62%. And then, what's the probability that somebody chose sugar given that they chose chocolate? A chocolate cone. No, chocolate ice cream. Sorry. Sugar. So let's go. Let's copy those. Sugar and chocolate. Sugar and chocolate, that's 51, over the total that chose chocolate, which is 98. Okay? Does that make sense? This one, and this one, and this one, and that one determine our denominator. So I'm going to put a little thing here. That's where I'm going to put my denominator. And that is that 98. So 98 is my denominator, but 51 is together the sugar and chocolate together. So sugar and chocolate is 51. So that's what is 51 over 98. Because, think about it. What's the probability that somebody chose sugar given that they chose chocolate? It can't be out of 159. It's got to be out of 98. But if they just said, what's the probability somebody chose sugar? What's the probability that somebody just chose sugar? Well, in that case, that would be 86 over 159, which is just, the total of 86, those that chose sugar cones, over the total, which is just 159. So that's kind of what that's going to look like. All right. And then if we go back here, we go to our calculator. Come on. There we go. Okay, so I'm going to go to my calculator. 51 divided by 98. Clear that. 51 divided by 98. And that gives us 0.5204, or 0.52 as a decimal. 0.52. 0.52, which as a percentage, move the decimal place over two places. 2 places. And so it's 52. With 2 more decimal places, 52.04. So it's 52.04%. And that's our answer. Sorry, this is 98. Okay. Excuse me, I'm erasing stuff all over here. Okay. Let's go to, this was example 3. Let's go to example 4. It says, create an example. I think there was a problem with the numbers here. They didn't quite work out because the numbers here add up to over 100. We're talking about percents. This is a percent, and percent is always per 100. And so your total sample space, when you're talking about percents, is 100%. This plus this plus this plus this have to add to 100%. And so there was a mistake. We made a mistake with the numbers. So we're just going to change this. We'll change this 21 to 12. Now, let's fill this in and kind of figure out what's going on. This is a little bit different than some of the other Venn diagrams that you've done, because it doesn't tell us those that have a garage and a pool. We don't have this. Normally, we want to start there if we can. But here, it talks about how many have 64% of the homes have just a garage. Maybe I'm wrong about this. 64% of the homes have just a garage. Well, that'd be right here. Excuse me, 64. 17% of the homes have a garage and a pool. I'm sorry, I'm wrong. This is 17. 17, no, not degrees, percent. 17%. And then I'm changing this to 12. So 12% have just a pool. So this is 12. We didn't have to do any of the subtraction like we did in the other one because they told us that they have just a garage. This is just a garage is outside those that have a pool. And then just a pool. Is it just a pool? That's the 12% that we put in there. So now we need to just add those together. 64, 17, and 12. Let's clear that. Excuse me. I need just adding that 3 so you can see what's going on here. 64 plus, what did I say? 17 and 12. Plus 17 plus 12 equals 93. So what percent have neither a garage or a pool? Well, the total sample space is 100. So we take 100% minus the 93% that have a garage or a pool, and it's 7. So in this sample, 7% of the population that was in this real estate ad do not have a garage or a pool. All right, now we're going to use this to answer the following probabilities. Excuse me. Remember that this is intersection, and we use it to write and. If it's helpful, you can think of this as like this. And. The intersection implies and. And who are those that have a garage and a pool? 17%. Just I don't think I'm not going to go over all of these for this, but just so you know, if I asked you to do this as a decimal and as a fraction, a decimal, and a percent, well, in this case, the percentages are given. That's 17%. That's what that means. But as a decimal, you're just moving the decimal place back 2 spaces. So this is equal. It's not even approximately equal. It's exactly equal to 0.17. And then also as a fraction, this is equal to 17/100ths. That's what percent means. It means per 100. And then sometimes you could simplify this, but 17 going to 100 and 17 is prime. So that is simplified. But you can always, try it in your calculator if you go back to your calculator. 17 divided by 100, and it gives you 0.17. And then if I hit math, enter, it gives me back that same fraction, 17/100ths. So then what's the probability of a garage given that they have a pool? Okay, the probability that they have a garage given that they have a pool. Again, we're first looking at garage and pool. Well, garage and pool, that's 17. Over those that have just a pool. And those that have just a pool, I have to add those. 17 plus 12, and that'd be 29. So 17 over 29. Now, in the interest of time, I don't want you to be watching this video all this time. I am in the building, but I'm in a meeting. I may or may not see you, so make sure that you're on task. You don't want me to show up and see you like mindlessly wandering off into space like you normally would do when I'm here anyways. Anywho, here we go. 17 over 29. Yeah, I'm not going to be prepared to say, okay, this is what this is a decimal, and this is, I'll just leave that as a box because that looks like a 0. And then what is this as a fraction, or as a percent, is it, something percent. Ay, perdón. Okay. So I'm just going to show the fractions on this. You can do the others on your own. What's the probability of a pool given that they have a garage? All right. So again, we're looking at pool and garage. That's 17 again. 17 over just garage. All right, just garage. That's 64 plus the 17. 64 plus 17, and 7 plus 4 is 11, and then I got 6 plus 2 is 8, so this is 17 over 81. Right? Pretty straightforward. And then we got the probability of a pool given they have no garage. So what's pool and no garage? Where is that? Pool? They have a pool, but no garage. That means it has to be in this circle for pool, but it has to be outside of this circle for garage. And that'd be this number right here. So it's 12. Our top number is 12 over the total that have no garage. Now, the total that have no garage are all of, let's use blue, no garage. Where's no garage? Well, it's outside of the garage. So it's all of this. And that means it includes not just the 12, but also the 7. And so we can add those 12 plus 7, 19. My denominator then is 19. Be careful when you're writing percentages. You got to make sure that this top number, this numerator, is no more than this denominator. Because if it's greater than, then you have a greater than 100% chance of something happening, and that's impossible. It's impossible for something to be more possible than certain. It's either 100% or 0 or something in between. It's never 110%. That's impossible. You cannot do that. All right. Wait, excuse me. Okay. All right, trying to erase it. Okay. Now, what's the probability of no garage and no pool? No garage, given that they don't have a pool. If you don't have a pool, what's the probability that you have a garage? Or excuse me, no garage. Okay, so we're gonna go. What is the no garage and no pool? Well, no garage is outside the garage, and no pool is outside the pool. So we're basically outside of this space. No garage and no pool, and that would just be 7. Is our numerator, but it's over the total of no pool. So just like in that last one, we're gonna say, what's the total that have no pool? Let's use green for no pool because you just have the grass. So no pool outside the pool, or get outside the pool. Don't get in the pool because there's no pool, and it's everything in here. So how many have no pool? 64 plus 7. And that would be 71. So it's 7 over 71. And once again, all of these may have a decimal and a percent and all of that. So be prepared to do that work there on your own. All right. And that's it. I mean, it's not super hard, but it can be a little bit tricky. So make sure you're doing your homework. Practice. That, I mean, if you look over at the piano picture, it's the little arrows on practice, unless some smart aleck moved it. Don't move it. The arrows on practice. So practice. If you do that now, you have any questions, you can ask me when we get back to class on Friday. And at Friday, we're over halfway through the unit. So sheesh, guys, stay on top of this. You got this. Do it. All right. Thanks, guys.